Okay, in our next section, third section, in our sequence and series chapter, we're going to be, as you can see, finding the sum of the first n terms of an arithmetic series. Now, remember, a series was the sum of the terms. So as we go forward, we've got finding the terms plus actually the summation. So in new notes, we have arithmetic series. Definition, the sum of the terms of an arithmetic sequence. Now remember, you should have that equation in your mind too, because if you need to find a certain term, you got to be able to do it. So you're thinking t sub n equals t sub 1 plus n minus 1 times d. Got to have that in your brain. How are you going to find the actual numbers in a sequence? But now we're saying we're going to add all those numbers in that sequence up. So the sum of the first n terms in an arithmetic series, where t sub 1 is the first term and t sub n is the nth term, will be nothing more than s sub n, the sum of this many terms, will be equal to n, our counter, how many terms, times, it looks like, the average of the first term and that nth term. And I won't say divided by 2 because I already said the word average, but some of you might want to think of it that way. Add the first term and the nth term and divide them by 2. But since I said average, that would be duplication. So there's a new formula you're going to need for the series. Okay? Sequence is just the listing of the terms. The sum of all those terms is referred to as a series again. And we had that and going to have more of that. So here we go. If I said, given the sequence 16, 12, 8, 4, etc., find the sum of the first 11 terms in this sequence, and that's how you want to read that. You want to say find s sub 11, because that doesn't mean find the 11th term. Okay, that capital S stands for the sum of the first 11 terms. So right now, looking at what we do and what we have, you got to do some retrospect. Think for a minute. We know t sub 1, the first term, is 16. And we can tell by looking at the pattern, because we have 4 terms given, that the constant difference is negative 4. So the very first thing is we better find that 11th term. So we would have to use the formula for finding the 11th term, and the explicit formula is the quickest because that'll get us there directly. So I think that's what I have here. T sub n equals t sub 1 plus n minus 1 times that constant difference. Let's plug in what we know. T sub 1 is 16. We want to find 11 terms, so n minus 1 is 10. Constant difference is a negative 4. Do the multiplication first, then add the 16 on. We should know that our 11th term in the sequence, if we kept going, so out here we had the first term, and then if we kept going down to that 11th term, there would be a negative 24 in that slot. So subtract 4, subtract 4, subtract 4. And you could have done that by hand because it wasn't that long a list. But you want to be able to get there quick. So efficiency again, and we've been preaching that as we go. So we want to use that explicit formula. Now, once we have that, we now have to add up those 11. And again, you could sit there with your calculator. Some of you probably would, and add up those 11 terms. But after a while, it's going to get pretty big. If they say find the 500, the sum of the first 500 terms, that would be a little ridiculous to do by hand. So, looking at this one, I've given you another way with our series formula, new formula. We will take s sub 11, because that's what we're supposed to be finding, the sum of those 11 terms, and it's nothing more than the index, so the 11 is that value, times in parentheses that first term and that 11th term. And we had the first given, we figured the 11th, and divide those by 2. Do that math, you can see. Times it out, and we should have a negative 44. You're going to say, well, that doesn't seem like that's a very big number. But remember, our list started out positive, ended up negative. there's probably a few more negative numbers in this list than there are positives, and so they're going to be canceling each other out as you do your summation, which is your series information. Okay? Your series is the sum of those 11 terms. Use of the new formula is good. So now if I put it in summation form again and said, whoa, what is this? Well, we're looking at, let's evaluate this. We want the summation of all terms from 1 to 21 following this little rule or this little algorithm. And so some of you would say, well, I've got a constant there, I've got a linear term. I'm going to show you two different ways we want to look at this. Okay, if you want to go with I'm a explicit situation, I'm terms in a sequence, some of you may do that. Some of you might like the summation rule. Both are okay, but you just need to like one over the other. Your brain has to see how they both work. When you're given the summation, so let's go back to our given information, probably most of you will say, well, I don't even know any of the terms. So calculating a few of them is always good. So if k is 1 in this, so we're looking for the first term, 5 plus 4 times 1, 4 times 1 is 4, plus 5 is 9. So we got a first term of 9. Put a 2 in. 4 times 2 is 8. 8 plus 5 is 13. Put a 3 in. 4 times 3 is 12, plus 5 is 17. So you can see right now that we have an arithmetic sequence that is being added by 4. So you have a constant difference of 4. So if you want to go back and use our arithmetic sequence to find that 21st term, that would be good. You could. So here is the first term plus n minus 1. Our sequence is 21, so we know we need to do n minus 1 of these calculations. That would be times 4, because our constant difference. That gave us 80. 80 plus 9 gave us 89. So our 21st term, out here somewhere in the list, this was the first term, this was the second, this was the third. So out here somewhere, if I fill this in, I have 21 of them. There's going to be an 89 sitting there. Okay, that's what you need to be thinking of, so frame of reference. So now if we want you to add those all up, and again, this is getting pretty big. Let's use our series or summation equation, which is take the series of those 21 terms, which is equal to n, that's 21, the locator of the index, times the first term plus that last term in the sequence, divided by 2. Do the math, we get 1029. You could also, as some people said, well, it's summation, it's summation. I could do the constant with the linear. That's what that represents. And so I know I have 21 5s here. And then I have 21 times the constant. The constant was the n, and n plus 1, divided by 2, times that constant out in front. So you can get some canceling going on here. You don't have to do it all in your head, but you probably would with the 21 times 11 right there, and multiply that by 4. So either way, notice, if you like the summation rules, or if you like our new series rule, you're going to get the same answer. But it is another way and another equation to memorize. And we're looking for that. So options, because maybe they're not going to give you all the information you need, or maybe it's going to be too big, too hard, too long. So we have two options. You could do it as a summation, break it into the constant and the linear, or you could use our arithmetic explicit equation to find the individual terms that are needed, and then use the arithmetic series equation to sum them all up fairly quickly. So work on those formulas and bring any questions you have to class.